So you have a circuit here which has a voltage source 30 volt and a current source 5 ampere, and you need to find out the current IL through this 10 ohm resistance. Okay, so let us do this problem first with KCL. Let us do this problem using KCL. Okay, first there are two nodes here and a ground node here. One node is here, so this A node and B node, and the voltages at this nodes be VB and VA. So applying KCL at this node A, let the currents be I1, I2, and this is IL. Let this be I3 and this be I4. Right, so there are 5 currents you need to find out. So applying KCL at node A. If you apply KCL at node A, I1 is entering and I2 and IL are leaving. I2 plus IL, right? I2 plus IL. So what is I1? I1 is nothing but 5 ampere. I1 is nothing but 5 ampere. What is I2? I2 is VA. I2 is VA minus 0 by 5. I2 is nothing but VA minus 0 by 5. And what is IL? IL is VA minus VB. VA minus VB divided by 10. Right? If this is your first equation, now applying KCL at node B. If you apply KCL at node B, what are the currents entering? IL and I3 are entering. So IL plus I3, they are entering, and what is leaving? Which current? I4 is leaving, right? So what is IL? IL is again VA minus VB by 10. VA minus VB by 10 plus I3. What is I3? I3 is 30 minus VB by 15. And this is equal to I4, which is nothing but VB by 5. Okay. So these are the two equations. From these two equations, you can solve VA and VB. So now VA is equal to 61 divided by 3 volts, and VB is equal to 11 volts. Okay, my calculation. If you see there is any mistake in the calculation, you can always tell me. So VA is equal to 61 by 3 volt and VB is equal to 11 volt. From there you can easily find out. IL. So what is IL? VA minus VB by 10. So IL is VA minus VB by 10. So VA minus VB by 10 is 61 minus 33 by 3. 61 minus 33 is 28 by 3 divided by 10. So 28 by 30. So IL is 28 by 30. VA minus VB by 10. Okay. So 61 by 3 minus 11 divided by 10. That is equal to 28 by 10. amperes. Next, we will try to do the same problem using KVL. Now, when we want to do this same problem using KVL, we will convert this current source and this resistance in parallel to a voltage source in series with the resistance. So, the value of that voltage source will be 5 ampere into 5 ohm, 25 volts, and the value of the series resistance will be 5 ohm. So, we have converted this part into this part, right? And the whole of the circuit remains same. Okay, so then the circuit is reduced as this, where we have taken the branch currents as small I1, small I2 and I3, and the loop currents as capital I1 and capital I2, and I have related those two quantities. Small I1 is equal to capital I1, small I2 is equal to capital I1 plus I2, and small I3 is capital I2. Now the equations that we will get are 20 I1 plus 5 I2 will be equal to 25 in the first loop, and in the second loop it will be 5 I1 plus 20 I2 equals to 30 in the second loop. So from these two equations you can easily solve capital I1 and I2. So capital I1 will be equal to 56 divided by 60, and capital I2 will be equal to 19 by 15. So what is I1? Capital I1 is again small I1. Small I1 is capital I1, and that is also your IL, the load current. That was also your load current. So you get your load current as 56 by 60 or 28 by 30, which was also your answer using KCL, which was also your answer using KCL. Okay. So in the next video, I will try to solve this same problem using superposition, Thevenin and Norton. Okay. In this video, I have solved this problem using KCL and KVL.